To take a look at work, in our first example, we will look at a fairly straightforward scenario. You simply apply a 150 Newton force for a distance of 15 meters. So you apply that force, the block begins to move, the block moves 15 meters, and at that point we want to know how much work was performed on this block. This is probably one of the most straightforward examples we can take a look at. So if we recognize that based on the fact that we're given a force and we're given a distance, we're going to utilize the force times distance times the cosine of the angle between those two, between the force and the distance. So let's list out what we know. We know that the force is 150. We know the distance is 15 meters. If we realize that the force is acting to the right, the distance is to the right, if I kind of lay those two arrows on top of one another, there is no angle formed between them. They're both going in the same direction. So theta in this case is simply going to be 0 because there is no separation in terms of the direction of those two variables. So now what I can do is I can simply plug in everything that I'm given, the 150, the 15, and the cosine of 0. Cosine of 0 actually just gives me +1, which for a conceptual note is telling me I'm adding energy. +1, positive work, adding energy. And we find that the amount of work that was performed on this block was 2,250 joules, which in this case would most likely be kinetic energy, assuming there's no friction. Otherwise, you might have a little bit of heat as well. But once we utilize the work to figure out how much energy that object has, now we can start to predict future motions of this object because we know the finite amount of energy it has to complete those actions.